Yeah, we are live now. Hello,
All right.
everyone. Um, yeah, we'll kick the show off straight away. Um, and hello to all our live listeners, of course. Good to have you here. Right, go time intro. Let's be having you.
Let's do it. It's go time.
Hello, and welcome to Go Time. I'm your friendly neighborhood Matt Ryer. Today, we're talking about the files and folders of your Go projects, big and small. Does the Holy Grail exist of this perfect single structure to rule them all? Or are we doomed to just be figuring this out for the rest of our miserable lives? Joining me today to figure this out is my co-host, Kris Brandow. Hey, Kris.
Hello. How are you doing today, Matt?
Oh, very good, thank you. I'm excited to learn about files and folders, actually, and I suspect there is a lot to learn, even though it's one of those things we kind of take for granted, don't we?
Yeah, for sure.
We've got a couple of experts in with us today to tell us about files and folders in your Go projects. Ben Johnson's here, staff engineer at Flyeo. Flyeo, Ben? Welcome.
Yeah, you nailed it there. Thank you. Yeah, thanks
Yeah.
for having me.
Welcome. Yeah, no. You're the author of BaltDB, Livestream, and you're working on a distributed SQLite implementation. That's right, isn't it?
Yeah, it's called LightFS. Yeah,
Nice.
trying to get all the SQLite everywhere.
Yeah, SQLite, all the things. And do you use files and folders? I mean, SQLite famously does.
Nope,
Oh, no.
none of them.
No.
No. Yeah, we do. Yeah, just single file database. It's great.
Oh, just one file. Interesting. What is it, though? What is a file? We're going to find out, don't worry. Chris James is also here. Chris, last time you were on Go Time, you said you were an unemployed bum, but now that's not true anymore, is it?
No, I'm an employed bum now. I'm working at Springer Nature, who are a scientific publisher. And yeah, I'm excited to be here to talk about files and folders.
Nice. Springer Nature. Is it sort of Jerry Springer based kind of science debate show?
Yeah, it's just like that, yeah.
Yeah. Where scientists just come out and they're like, say controversial things, and then people are like fighting, and then they bring out the brother-in-law.
Yeah, it's somewhat like that, yeah.
Yeah. All right, cool. So let's just take a step back a minute. But first of all, like, this question is probably, of all the questions I get, this is probably the one I get the most, which is what's the structure? How do I lay out my projects? And if you think back to Ruby on Rails days, Ruby on Rails did something very interesting where they basically didn't give you a choice in the file structure and the folders. Everything was by convention. So if you wanted to it had the kind of model view controller pattern. Models were all in a folder called models. Views were in views. Controllers were in controllers. And actually, it had meaning. The folder structure had meaning. Then there's other tech and other languages where that's not the case at all, and you really do all your linking and you're sort of stitching it together somewhat manually, and you can kind of do anything. Goes somewhere in the middle, I think, of those two. But if we take a big old step back, do we actually know what files and folders are? Like, what literally are they on the computer?
No, we don't. I don't think any of us do.
Don't know,
No,
do we?
I mean, it's a great convention that we've built. For sure. I mean, Chris has mentioned this before, but yeah, just like it's something we just don't think about day to day.
Yeah, they're just there. But like when you make a folder, what happens? Does a folder exist somewhere? Is it just like in a table of contents? How does it literally work?
Yeah, I mean, basically we have file systems and metadata, and they're all pointing to inodes, and there's all kinds of, stuff in there that's all hidden away. But, at the end of the day, they just look like these simple constructs for us. It's great.
Yeah. Sounds like you don't know as well, Ben.
Yeah, that was all just made up on the spot.
No, but inodes I've heard of. I've touched these concepts as well in various projects. You tend to become an expert in them when you need to. But when you're doing SQLite work, you mentioned that it's just a single file. So do you have to sort of know? Are you seeking across the file? Do you like keep track of like distances and offsets and things like that in the file?
Yeah, so a lot of file systems are, page based. So SQLite kind of builds on top of that file system pages. So a lot of times they're like 4K pages and they're evenly distributed through a database. And then internally they're kind of structured, or logically they're structured as like a B tree. So there's a lot of like jumping around to these fixed blocks. BoltDB was the same way, 4K blocks. And like with the SQLite stuff, a lot of the stuff I actually do a Fuse implementation. So it's like a file system in user space. So we actually intercept calls to SQLite so we can extract out where the transactions work at or start and begin or start and end. So there's a lot of jumping around, and there's a lot of little concepts in file systems you really don't learn until it like bites you. And you're like, oh, that's really good to know that this file name can point to the same inode across two different files, and weird little things like you can delete a file, but you can still have a handle to it because you're just deleting the name of the pointer to it. So, and that differs by file systems and good stuff. Yeah.
Yeah, same. I've done projects before where using inodes, symlinks and hard links, like digging into all that stuff. Like, it turns out there is quite a lot going on, but it is nice, I guess. We just don't have to worry about it. Go gives us standard library packages for dealing with the file system. Now, how does that work? Since you mentioned that it's different on every kind of machine, like Mac. Files and directories and things work differently on a Mac to Windows. Does Go literally just have an implementation per supported architecture?
Yeah, it tries to abstract away a lot of that stuff, and I know we haven't gotten to unpopular opinions yet, but Rust actually does some better things around those different implementations, whereas in Go, you kind of have to know some of those tricks. Where like if you're gonna remove a file on Unix, that'll work great even if you have it open. But if you do it on Windows and you still have the file handle open, a lot of times it'll error out. So it's one of those things you just kind of learn when you actually dive in and start running stuff in production.
Yeah. Yeah. So Kris James, have you heard of the term inode before?
No. Could you please explain to me what an inode is? It sounds like an Apple thing, but I assume it isn't.
Yeah, it does. It sounds like a new project. What would it be though? A node? It's too generic.
Maybe when they do teleportation.
Yeah.
Sounds like that kind of thing.
Yeah. They probably already reserved the name, to be honest, in anticipation of that. I look forward to it. What do you keep in your files, Kris?
Computer codes.
Yeah.
Mainly.
It's your
my
own business,
poems,
though, really, isn't it?
Song lyrics, my diary,
Any
some
novels?
notes. No. Yeah, lots of stuff really. I mean, I think for me, like as Ben mentioned, I think files are such a wonderful abstraction in general that most of the time you really don't have to care about the details. Like we should all dream to make an abstraction that is so kind of ubiquitous and easy to understand. Like I remember when I first used a computer when I was like 12 or whatever, and the idea of files and folders clicked for me instantly. Like it was like, oh yeah, this is obvious. I'm just putting files of text here and there, and it all makes sense. So I think it's whoever came up with it did a good job. I assume there's a number of people really, but yeah.
Yeah, it's funny. Do you use like the physical paper files in your real life still?
Not so much. I think they're mainly just stuffed away in a drawer somewhere, and certainly not as organized as my computer files, I'd say.
Nice. So Go files and folders are meaningful in Go. I think the obvious thing is, our Go files are .go. They have the .go extension. There's also, of course, _test.go files. And they're different, aren't they, to normal Go files? That's where test code goes. And when you build, that stuff's ignored. And when you run your test, that stuff is included. Are there any other rules that we need to be aware of for people
There's
around
also
files and
the
folders?
underscore operating system or underscore architecture. If you put that at the end of a file, just like underscore test, it'll only compile or only be included for that operating system or architecture. So don't
Yeah.
don't name things underscore Windows unless you only want them to be imported for Windows.
Yeah, that's interesting. How do you feel about that? Because you can do it with build tags as well, can't you?
Yeah, I heard an argument once that there's like a good reason for having that instead of build tags. I don't remember it off the top of my head. It can certainly keep your files like a little bit cleaner overall, but then when you're actually looking at a file, you can kind of forget that, oh, this one's only for Windows or this one's only for Mac OS.
Yeah. Yeah, it can be awkward if you edit the wrong file and then it sort of doesn't take any effect because it's not for that architecture. So it's worth definitely knowing about that one. Another one, of course, folder is a package in Go. So the Go files inside a folder, they are grouped in a meaningful way in Go, aren't they?
Yeah. The one exception there is the underscore test package, which I think is very underutilized in the community. That's one of my favorite features. Just kind of being able to separate your test code out. Actually, to explain what it is. So if you have files, at the top you put package, yada, yada, yada. And if you have you can also have test files in there, and you can have those test files be in a separate package, but in the same folder. So they can be at the top it'll say package, yada, 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 underscore test. And I think it's a great way you can kind of use your package code as an external package. So you're still, treating it as you're just like a user of that code. So you can only use exported stuff. You can only do, you have to prefix everything with package names. But I think it's a great way to kind of abstract away your tests from your actual code.
Yeah. So they're still inside the same folder, but they're allowed a different package. And is that is that like special? Is that because the underscore test code is kind of explicitly handled differently? Is it? Yeah. So is that a side effect or was that a design decision? Do you know?
No, I believe it's a design decision. I mean, that's the only name you can actually use as a separate package inside of a single directory.
Right.
I find I definitely try to do that by default when I'm writing tests. And reason for that, because it puts the kind of really healthy constraints that Ben was talking about. And I've definitely been through an experience where, we started projects and I just think we weren't aware of the underscore test thing. So we wrote a bunch of tests and things and we're like, oh, this is a cool thing. So we add the underscore test and then we realize how bad the design of our package was because our tests were coupled to so much stuff that it just didn't need to be right. So for me, that's why it's a really good technique because tests act as documentation for your code. So therefore, you really want to consume it the same constraints that someone importing your package to use your code for real. Make sure they have the same constraints as well. I also think another thing that's quite underutilized is the internal folder, which is another thing I only really learned about, I don't know, maybe like 2 years ago. And now I'm struggling to think how to explain it. But basically what it means is if you have a package which has an internal folder within it, only the parents of that internal package can import things from the internal thing. I feel like I really butchered explaining that, but hopefully it makes sense.
That's close enough.
What that means is that it gives you another kind of way of sharing code without having to share it with the entire code base, right? Yeah. So without this, you can make shareable code, but it means anything can import it unless you have circular dependencies. So internal gives you kind of another way of just having shared code, but just not with everything, which is a really powerful technique.
I do feel that internal is heavily overused inside closed source code bases, which I don't like. Like people, instead of fixing whatever internal problems you're having where people are importing code they're not supposed to, people are like, I will just make it very painful for you to import this. And it's like you should probably solve those internal problems instead of trying to force your code base into some sort of way of functioning. I do think it's useful for external, if you're a library maintainer, I think it could be very useful. But still, it's of limited use most of the time. But I think if you're in a spot where you're for some reason, political or otherwise, you can't get people to stop importing your code, it's a very useful tool. But I shudder every time I see someone using it. That's the first thing they do. They make a new repo and they're like, I'm gonna put everything under internal, and I'm like, that. No, please stop. Please halt. Don't do that.
Yeah, I find you have to make a PR to pull out a piece of code, and then you have to rename all the imports that code has in the code base just to be able to use that piece of code. So I agree with you. Like in closed source, I don't think it makes a lot of sense.
But is it not a good signal though that this is kind of logically contained in this world and isn't expected to be used outside of it? Because there is something about the blast radius of these internal packages. If you change them, hopefully, if you've only used them in packages alongside that folder, then you're quite safe. It won't be, it's at least in one place. Whereas if it has been imported elsewhere, you might be breaking things without realizing it. So in a way, it's a nice signal. But Kris, James, do you do that by default then? Do you use internal by default?
No, so I'm trying to recall an example where we used it. I think we had some kind of like HTTP handler stuff, code that was to do with HTTP handlers that we reused around a bunch of HTTP handlers, but was totally inappropriate to import elsewhere in the project. Now you could argue, well, just make it private to the package, but there was definitely a reason that we had we wanted to share it with some multiple bits, but only within a certain part of our system. I agree that just sticking internal at the start of your project, I think anything by default is a bit dangerous because you're kind of turning off your brain and just going, well, I'll just do this by default. I think there are very few things in this world where you should do things by default. I think, sadly, as engineers, we have to engage our brains sometime.
I also think on a level it encourages people, it encourages package sprawl in a way that I tend to dislike, because I think people are like, oh, well, I don't want people to use this package externally, and it's like, well, does that need to be its own separate package, or could you just have one larger package instead of splitting things out? So I think there is a slight tendency among some Go engineers to just oh, I'm gonna have a bunch of little tiny packages, and it's like, this isn't Java. Your package is not you don't need to make them small. You just need to make them appropriately scoped. Yeah. And what that means is different for each person, but if I tend to see that if you're using internal a lot, you might have misscoped your packages a little bit, and that's something that you might want to address and fix.
Yeah, so that's
actually go ahead.
No, please.
One thing I actually like internal for that I haven't seen, I guess, a whole lot. I like using it for almost like utility functions for packages that I use, especially standard library packages. So I might have a testing util package inside internal where I don't necessarily want anyone else to use it, and all my test code might use these helper functions, that kind of thing. I don't use it extensively, but I do find those kind of things are helpful to kind of push it out somewhere that's not just dumped in a package in my code. Kind of cleans up the rest of the code, I feel like. But that's kind of more of a side suggestion.
But Kris, you said something interesting too, which was if you have lots of these folders, that could be a sign that you're sort of overdoing it. So that tells me then that the files and folders that we end up with in a Go project are or should be influenced by the design of our system. And that might sound like an obvious thing, but I think I don't know if that's always the case for different languages. But there's something meaningful, isn't there, about what folders we choose and therefore what packages we're creating.
Yeah. I think Go is, on the spectrum of you can kind of put files wherever and you can write some shell scripts to make it figure out, to the you're using Rails and everything is very prescriptive. I think Go tends to skew more toward the latter side of that. I remember in PHP, you'd have class autoloading where you put things in a special place and it automatically load them from that place or things like that. I think with Go, you have much more flexibility there to just kind of bunch everything together and be kind of fine in the beginning stages. I think that's generally what people should embrace along that. You're starting a new project, just start with one package. And kind of grow it from there, and then figure out what the boundaries of the packages you need are after you've already kind of written them or after you've developed them. I think there's a lot of people will, in the way that Rails is set up, think oh, I gotta split off my HTTP handlers over here and my database access over here and this other thing over here, and it's well, you don't have to start with that. If that's where your project leads and that makes sense as division, then sure, go do that. But there's other styles that your project might fall into that maybe you want all those things together instead, and you want to do more domain-specific packages where you have all of those, the HTTP handlers, the database access, all of that grouped into a package, and you have multiple packages. Like there's many different options you have, and that is because of the flexibility that Go has, where it's just like, oh, your packages mean whatever you like them to mean. Please define them for yourself.
Yeah, and aside from internal, interestingly, sub-packages aren't like subfolders aren't sub-packages in any way. This is another thing that I've seen in other languages where you have a subfolder, and that is to it's to do with the scoping. It's a bit like how the internal thing limits what's able to then import it. But we have to include the full path, of course, but it doesn't. There's no special relationship between a parent and a child package, is there?
No, just relationship on the file system.
Yeah, so that's interesting, I think.
Yeah, it's mostly just communicating. Like you might be grouping things. Like in the standard library, you see stuff in like the encoding package or the archive package. It's not a strict relationship. Just it helps people to understand the groups.
Yeah, in a way, they're sub packages, you could say, but there's nothing enforced by the tools.
Yeah, that's the term I usually use. Sub package.
Right.
It's easier than just I don't know what else you call them.
Yeah, they're semantic things, not syntactic things. It's just like, oh, this is it's a sub package because we've decided it's a sub package, not because of where it sits necessarily.
Mm-hmm.
One thing I'll touch on with what Kris was saying was like we don't have there's some flexibility in Go, but I think a lot of package structure is really derived by the restriction of no circular dependencies. Like in most like a lot of languages like Ruby or Java, you can kind of go willy-nilly and put your packages anywhere, or modules, whatever you want to call them. And at the end of the day, it's kind of bike shedding. It doesn't really matter. There's nice groupings. Everyone has their own taste, but in Go, there's actually consequences to how you structure your packages, and because of that circular dependency issue.
I think that's a really wonderful thing about Go. I think I reflect on Go a lot, and it kind of subtly enforces a lot of sort of design lessons learnt over the past 50 years, and people often don't appreciate that, right? Because for a long time I've been taught dependency should only go one way, right? Like your handler can depend on your domain, but your domain shouldn't be coupled to HTTP, right? And that's just something that's been drilled into me since the start. But Go, I think, is the first language I've used where it's actually properly enforced that. Like, it just won't let you do it. A lot of people get frustrated with that circular dependency error, and you see lots of people asking questions about it. But to me, it's just a wonderful signal that, there's something fishy in your design. You need to think about this and go, apply that rule. Dependencies should only go in one direction.
Yeah, so tell us a little bit about that problem that happens with this. You have these two packages and they are interacting in some way. Maybe you've got some interfaces so that they interact in a sort of nice decoupled way. But sometimes you find that one of them does then need to depend on the other and vice versa. And so if you have those two packages and they both kind of need to depend on each other, how do you solve that?
Sure, yeah. So, there's different takes on this in the community. I think that one common thing when you see two packages that need to depend on each other, people will kind of split off a third package to put the other thing in there, and then both those packages can depend on that one third package.
Seems fair
and
enough.
then that kind of explodes over time. You keep doing that over and over again, and that's when you get a ton of packages. So for me, the way I structure things is I try to start from what I call the application domain, just kind of like the things in your application that are, they don't depend on a technology. They're not related to your database or your web handlers or anything like that. It's just like your user, your customer, those kind of objects. I put those in the root directory, and then all the other sub packages kind of reference that. So your database can might have like a user database service where it can actually fetch users and communicate like that, and that can implement an interface inside of your domain package, your root package. And then your HTTP package, your web package, might then depend on your interface inside that root package. So you're not depending directly on the database, or your database isn't depending directly on your web handler. So there's some disconnect there, and you can do some interesting things around mocking around that as well if you need to. Depends on that fits your use case. And I think that works well generally. I think that you don't have to be super strict around that. I think you can start depending down the stack. So your web handler can depend on the database, but you don't necessarily want your database to depend on your web handlers. So it really depends on how you structure your project, how complicated it gets, what dependencies you have.
Yeah.
Mocking things like your database isn't always that useful. Mocking things like S3 is super useful when it costs a lot of money. So, it just depends on the use case.
Yeah, I feel like when you have multiple, like if you have two packages that are kind of depending on each other, I tend to see that as a signal that maybe those shouldn't be two different packages, and maybe you should try and merge them. And merging is definitely more challenging because you got to go rename a bunch of stuff, decide what the new package name will be, and all of that. But that helps prevent that kind of package explosion that Ben was talking about, where you just wind up with like more and more and more and more packages as things tend to like grow over time.
Yeah.
And it's easier to merge it now than to merge, 3 or 5 or 7 or 50 packages later when you realize you're kind of stuck. I've definitely had code bases I've been in before where it's just like, okay, well, we can just not avoid this circular dependency, and I've had to do some pretty egregious stuff to just make it work, and then try to unwind all of that and kind of get everything back into a better state. So even though it might be painful now to try and merge these two packages, merging two packages is going to be a lot easier than trying to merge, many other packages down the line.
Yeah. So Kris, Brandow, then, do you err on the side of having sort of one folder and everything just sort of merged in the beginning and break it out later, or do you try and do something based on your experience of what you think would work?
It depends. Usually, if I'm building an application of some sort, like some sort of executable or something like a microservice going to run on a server, I just start with one package, and then as I need to break things out, I start breaking things out. If it's a library and I have an understanding of the shape that library ultimately needs to take, I might start breaking out packages early, but I do tend to start with just one package and then kind of break things out over time and go from there. So unless it's like you super understand the domain of what you're trying to build, and like maybe it's something you've already built before and you're building like a new version of it to clean everything up, then sure, start with multiple packages. But I think for anything else, especially if you're just exploring, it's okay to just have one package. It's okay to have one package with even a lot of files in it. Like that's not necessarily a bad thing. There's not like at least I tend to think there's not like a golden number of files for a package. It all just depends on the context.
Yeah. Yeah, they can actually be easier to find things. And I find that because I do the same thing. I have usually quite a big main folder, whether it's called, it usually is called main if it's the main command. We can talk about that in a minute. I'll often have that lots and lots of files and then use file names to group them up into something that's kind of meaningful and logical. And yeah, the tooling is there's just no problem. I remember on older machines, there were limits on files, probably still are, but I'm sure they're just way beyond anything we're going to get to probably.
Yeah, I think like maybe with fat file systems where it's like a 4 gig max, but if you have a 4 gig file, that's
4 gig code file. Break that into a couple of packages.
For some older machines, I found that not even that much older, but like running like go thumped on like a 10,000 line file takes like that just like split second. That's just a little too long, and I save a lot, so it just annoys me every time it has to like catch itself.
10,000 for a single file is definitely a point at which you should be
split.
exploring. I mean, I have run across code bases that I think like have 20,000 lines of code in one file, which is just like, okay, we need to do something about this.
Yeah. I sometimes feel like people take the don't do premature abstraction thing a little too far sometimes. I don't think, a file with 5,000 lines of it is acceptable in my view. It's like, just break it out a little bit, particularly because with files in Go, like, it's not like you can import from 2 files in the same folder, right? Like, it's not a big deal to just
There's no difference.
almost cut a file in half and just put it in a different file,
Just have part 1 and part 2, would you?
Yeah, that's fine.
Yeah.
Part 1.go and part 2.go.
I like that.
I would add a caveat. As long as like if the 5,000 lines is like one type for some reason, please don't split it across files, because I've run into that as well, where people have split types across files in Go, and it's like one of the most frustrating things. Like, where is this method? This method is I cannot. Oh, it's in this other file. That's annoying. And then you wind up with these smaller files.
That's a pretty good tip there then for people. Like put the stuff that's related together in one file. I think it's a usability thing. Like, we are users of our code base. So think about the user experience of the code base. I think that's quite a healthy way to think about this. But yeah, so with the internal folder, we know is different and special. There's also, I've seen the CMD folder and PKG folders for the command and for the packages. What are those folders? Can someone just explain what they are?
Sure, yeah. So the CMD folder, a lot of times that's the subdirectory off the root, and then inside of that you have other subdirectories based on the name of the actual binary you want to produce. And this is super helpful just to kind of, if you want to abstract or separate out your command, your binary from your actual root domain package. That's how I do it. Or if you have multiple binaries you want to produce. So a lot of times if you see like in Kubernetes, you have like kubectl, like a control binary that you might produce, and you might actually have a server as well. So that's a good instance where you have 2 separate binaries. So that's a great way to split them out. One caveat there is that stuff that you have in one of those binaries, you can't import from the other binary, because they're both main packages, and that's another restriction on packages. As far as the PKG folder though, I don't like the PKG folder personally. I think a lot of people in the community generally don't. It's, your structure, your folder structure is your packages, so I don't think there's a usefulness to necessarily separating out kind of library packages from your binary packages. Just put it all in the root.
Yeah. I wondered if PKG originally they were supposed to be imported, where others perhaps weren't.
And like years and years and years and years ago, even before DEP, like in the old days, I ran across a code base that used PKG, but it used it specifically so that you could have imports that didn't have like the qualified name on it. They wound up looking like standard library packages, which was very annoying. But the way that you could do that is by having a PKG folder and then basically pointing your Go path at or adding to your Go path the repository you're working on. And so people did that sometimes. Very annoying to work on, though. Yeah,
so that's...
you come across a package that's just like, it's just like a single word or like a word and a subdirectory, and you're like, is that? I don't think that's in the standard library. Like, what is that? It's like, oh, no, that's not it. That's just one of our things because we have this PKG folder here.
So I bet you that's where it came from, because it's an unusual thing, but that makes sense because the old Go path used to, when you just did an import, used to look in all the Go path folders for a PKG folder.
Yeah.
So that's probably where it came from. And there is something aesthetic about just doing that. But one of the great things about importing things in Go, I think, is the fact you see the full URL of the project often. It's a shame they don't match exactly for sub packages, honestly. And actually, I wish GitHub would. In fact, they could fix that, I think, if they wanted to. So just shout out there to our GitHub friends. But like having it when you open a file and you've got github.com/ your favorite package in there, you know exactly where it is. You know it's an external package. It's a nice signal. I agree with you, Kris, that just having the package name, although I can see the aesthetic appeal, it's confusing. You'd think it was a standard library package.
Yeah.
Ben, do you wish that main was importable?
Yes, I actually do. I find that, like, I always think of my application kind of in layers, and then kind of the outermost layer is that binary. Or not, it's one of the most outer layers is the binary, and then outside of that is the main_test, which will test that main program. But if you have multiple binaries, sometimes you want to integration test them all together, and that would be nice to be able to import to, another layer, kind of another package to test those.
Yeah.
So that's my main annoyance. I mean, you can just compile out the binaries and run the binaries themselves, but it's a minor annoyance, really.
Yeah, but that is a bit annoying. I was going to say something else. I've forgotten it. One for the editors.
I feel like that has led also to people having very small or very thin main packages where it's just like, oh, I'm just calling into another package that is my actual application, and that's all it does. It's just like package main, and then you have a func main and just calls the thing and then returns, because you can't import main, and that's can be annoying.
I think it's nice because I definitely strive to keep main as tiny as possible, and to have some kind of function that takes like standard in and standard out, and then it means I can actually test my my application, if not the actual compiled binary, as a separate thing. I'm actually quite a fan of that sort of thing.
But so I do that with a run function or something, but that's inside the same file. Do you have all your stuff pulled out into a different package?
Well, to be honest, I don't think I've been particularly consistent with it either way. I think in some projects I have just had a run function just living in the same packet in the main package.
Yeah.
Sometimes I felt the need to have it separately, but yeah, it's just in terms of just peeling away as much as I can so I can write tests around as much as I can without having to actually compile like the big scary program. I think it's quite nice. But it's again, it seems so trite to say, but context is important, right? Like if you're just building a fairly small program, like a script or something, it's probably not worth going through all these hoops to do that. If you're building something, dare I say, a little more enterprisey, then maybe you do want to do that.
Mm-hmm. Yeah, if you're building something that's like production level, then you might want to have more of just to get some more testing or ease the testing of it. But yeah, if you're just like doing a proof of concept or a prototype, like you can just shove everything into a main function if you want. Like, like don't get fancy before you need to get fancy.
So is there one project structure then that we prefer? Is there a project structure that in most cases is just good, and like with GoFumped, how we like the fact that all our Go code looks the same. Would we not benefit if we could all just agree on this is the single structure of how we do all our things? And this leads me on to the project layout package, which is quite an interesting. It's on GitHub, and there's a kind of Go standards repo for package layout. Tell us a little bit about this, because it's quite a popular package.
Yeah, it's a package on GitHub that has been it's a point of contention, I would say, in the community. There's a lot of questions. Like people will come to the Gophers Slack, and I've seen a lot of questions on there. I know like Tim Heckman answers a lot of these questions, and other people, where people will come and say, "Hey, I found this, standards repo out here. This is how I'm supposed to do my project layout." And there's a lot of things that people in the community disagree with that are in that repo. And I think that it leads. It's it's not all wrong or anything. And by no means I think that there's like a single one package structure for everyone. But I think that the kind of community guidelines we've kind of come together on, I think it can lead people astray in some ways and confuse people. And especially with the name of Golang standards, I think gives the impression that it is a sanctioned repo, and it's not.
Yeah. I think Russ Cox even wrote or commented about this, and we'll put this little bit of drama for you, and we'll pop this in the show notes for you. You can go down that thread yourselves. But it does have some interesting points in it, and actually one of the folders it mentions, it talks about internal, the CMD, the package folder, vendor folders as well. Are they still a thing?
Yeah, they can be. I mean, I've seen people that will use vendor. One interesting use I had for vendor recently was I had a project that would pull in a private repo, and I needed to build it up on a third-party service. And you can actually, the way that some of these things work, where you can push up your project structure, your local structure, and it'll run it like Heroku kind of thing. It can push up whatever code is in your local repo. So it's nice to just be able to vendor that in, and then it pushes the whole thing up instead of having to pull down and send up keys like API keys for GitHub. That's one option. I don't know that that's super common, but generally, I generally avoid it for most open source projects.
Yeah,
Feels like the vendor is like a relic of the past as well. Like it was that we really, really needed something. What was it, like 6-7 years ago when we had, the battle days of, it just pulls whatever's on main. Like, good luck. Vendor definitely helped with dependency management, but now that we have modules, it doesn't seem like it's as useful as it was in the past.
Yeah, I would agree with you. I think unless you have a really good use for it, or a really good use case, you should probably avoid it. I find like some CI systems, sometimes it works better for those, but yeah, I'd avoid it generally.
So, are there any signs that we've got our structure wrong? Like, are there sort of things we find ourselves doing again and again that are red flags that we should pay attention to?
Yeah, like when this was brought up on the Twitters, we talk about files and folders and things. What I believe is that when we say things like context is important, that's not a particularly actionable piece of advice to people, right? Like, context is important. What does that mean, right? I think a more useful thing to talk about are how do you know that your structure is working for you, right? And if you can get used to understanding those signs and listening for those signals, you'll be able to design the packages and things that you need for your context. So when I'm coaching less experienced people about this is the thing I really lean on. I don't like prescribe a particular structure or anything like that. I just say, look, let's just listen to the signals you get. So for instance, if you find yourself having to constantly rework your tests, when you change your packages and things, that probably means that your package design isn't quite right, and maybe things are coupled to things that they shouldn't be, or maybe your cohesion's lost, so you need to bring things closer together. Like another thing I love to look at is the blast radius of change. So how often have you worked on a project where someone's asked you to make what sounds like a small change, and then by the end of it, you've changed 20 files, and you think to yourself, is this reasonable? Like, is it reasonable I had to change so many things just to do this tiny change? And quite often it's just easy to ignore that signal and just kind of move on and, okay, I'll go pick up the next ticket of Jira and just go on with my life, right? But you should listen to those signals. There's a lack of cohesion in your code base. Things are often too scattered apart, and you need to think about bringing things together. And finally, the other thing is having a sense of locality. So if engineers come into the code base, and again, they don't know, they've been asked to do something and they just have no idea where to go or where to start, you're not giving enough signals with your code base. So, we talked earlier about how files and folders are a wonderful metaphor, and metaphors are such a powerful thing for software engineers. And quite often we can use folders and things to create these metaphors in people's minds so that they can find the correct thing to change whatever they need to change. And there are lots of other signals like that, but for me, that's the thing I try to get engineers to focus on, just listening to your code and trying to understand why is it difficult to make the changes that we need to do, and then using that feedback loop to change your design.
Yeah, I'd agree with everything Kris is saying. I think those are great signals. I think that some concrete ways as well that are good for kind of code smells. I think that if you have a lot of the same prefix on different types, that could be an example of where things might need to be split off. We look at like the standard library. I think everyone really likes the standard library layout, the package layout. It all just kind of fits because they all kind of layer on top of each other really well. And I think a useful exercise is like one example where I think it kind of did poorly, in my opinion, is the net package, where you have just this gigantic package where it has like every network related thing ever put into it. And not trying to critique the Go team, they're great. But I think that in hindsight, I think that you could split things out. If you see there's IP address, there's IP listener, or not IP, the TCP listener, TCP address, all those things. I think those could be split out into a TCP/IP, a TCP/TCP package. Because you have a network stack where it kind of layers those things naturally, and that IP doesn't depend on a TCP. It's vice versa. That kind of single dependency. So I think that's a good way to look at it, and kind of as a code smell.
Yeah, that's an interesting point. I like Kris what you said. When you do a PR that's got 20 files have changed because of your structure. Those PRs even are harder to review. It's harder to really understand what's going on, and it's harder to just by reading it really have a sense of what's going on. But that's probably true for any kind of abstractions. Like, that is a price we pay by doing an abstraction. So it's like, yeah, we try not to do loads of abstractions, but also, thing is, the abstractions are really what unlocks kind of phenomenal things when we get them right. So I think, yeah, that's quite important. And yeah, Ben, your point was interesting. With the net package being so big, if it's an API that people are going to be consuming, you can't really do that trick of start with a main and break it out later when things become obvious, because people are going to be kind of relying on the structures there. Are there other downsides, Ben, to just having one folder with everything in?
I think understanding kind of how things are structured and how they relate to each other in your project. I think you don't really get a sense of that necessarily just with a single, Go doc page that goes forever. So I think that can be an issue. But no, I think that, I don't think there's anything wrong with starting with a single one. And even with Go, like, there's no real guarantees up until we got to 1.0. What was it, 10, 11 years ago? So before then, we depended on all kinds of things that changed. But, once you actually get to that 1.0 part, you're really just saying, hey, this is the structure. We're running with it. It's not going to change. And I think that's the most important piece.
And I think there are like tools now, or there's more tooling than there was before to help migrate. So I think like GoFix isn't as big of a thing as it was in the early days, but having tooling like that can help to auto migrate your code. If you do like, okay, I've taken this type and now I've moved it to this other package, and now you can just run this thing and it just does all that for you. That can be helpful, along with like aliases and that sort of thing. So it's not, I think over the past few years, we've gotten tools to make it a bit easier to do those migrations of things out of packages and breaking larger packages into smaller ones. But I think on the question of like, how do you know if your package structure is like wrong or if things are wrong, I think that really it comes down to like, can you justify why things are the way they are, and do you like that? Because if you don't like that, then it's wrong and you should change it. But like, if when you put in a single PR, you touch 20 files, and you're like, oh yeah, but like this is the reason why it's like this, and it's like a coherent, explainable thing, then it's like, okay, well then it's not wrong. It's annoying, but that's like a trade-off that you've chosen. So I think like, the term wrong really depends on like, have you sat down and analyzed the circumstances that you're in, and are you happy with those circumstances or not?
Yeah, I think that's a really good point.
I think it's useful too, like to go back to code you haven't touched in 6 months, and it just looks god awful. You're like, oh yeah, that package structure was not right, and like it gives you a lot of sense of what feels right and what doesn't.
Yeah, I did that once recently. Went back to an old package, and there was just a folder in there called folder. So
I guess it's not
did
wrong.
it deal with folders though? If it was a folder management package, then that might be okay.
Yeah. No comment. Well, speak of no comment, it's that time again. It's time for our unpopular opinions.
Unpopular opinion. You what? I actually think you should probably leave. Unpopular opinion.
Okay, who's got a delicious, juicy, controversial opinion for us? This is the internet. We need controversy. Did you say controversy or controversy?
Controversy is the correct way to say it.
Okay. Kris, Brandow?
I don't even controversy. I think I say.
You're not Kris Brandow.
It's controversy. Like, come on.
Okay. Yeah, see? Controversial, isn't it? Or controversial, as I say. All right, who's got an unpopular opinion for us?
I'm happy to start.
Yes, please, Ben.
My unpopular opinion is that like the most widely touted features in Go, so like channels, interfaces, I think are some of the not the worst features, but kind of the most misused features of the language. And that I feel like people that come into the language, they hear about those things, and then they just they can get confused on, like, a lot of times channels are not the right answer for things. Like a mutex is awesome. You should probably use a mutex. Or like kicking off 1,000 Go routines is probably not a good idea. You should, there's a lot of management around those constructs that I think that people don't see. So I think those popular ideas and constructs are not always great.
But those Go routines are really cheap to make, and you can make just 1 million of them really easy, Ben. So
they're super easy to make. I agree. Yeah.
Yeah.
And they're
And
also
then
very
those
easy to
ooms are
leak.
great too.
I think it's interesting. I think most of the time when you're using channels or Go routines, it's like something else has done it for you, so you don't need to do it yourself. Like, yeah, you use Go routines all the time in like an HTTP server, but you don't need to spawn Go routines. I think like they're good features to have in the language, but not necessarily features that you should be clamoring to use.
Yeah.
So I agree with you, Ben. I think that should be a popular opinion. Don't make atrocious packages or applications filled with channels. We've all made that mistake. Please stop.
Yes, I mean I'm with you actually. I tend to all the old code I had that was channels. I've tend to end up refactoring away in favor of just a simple mutex or something. I just find the semantics actually a lot easier to deal with, and I always want to, top tip. I always keep the locking and all that code very local, so you can see where things are locked, where they're released, probably in one function if I can, and break out the actual execution elsewhere. And the other thing I like to say is for packages, it's so tempting to want to, like, if you're delivering a package that's going to do some work, it is so tempting to want to solve that problem of doing loads of that work and filling up the CPU and just really blasting through it. But actually, that's harder for people to use. It's easier, I think, for people to implement their own concurrency and their own kinds of things, because they're going to understand it more, their situation. Just writing, as long as you have type safe, like, thread safe types and things, which you can get with the atomic package. Yeah, I think it's worth doing.
It's not a very bad opinion. Sorry.
Yeah, it might be really popular, that one, but we'll see. Yeah, still appreciate it.
Just to add to that, like I think quite often counterintuitively adding concurrency slows things down, right? Like, because concurrency isn't free. Like, you might think that like suddenly you've made your computer do things 4 times faster or whatever, but actually in practice it's slower. I mean, that's why it's always best to benchmark things first, and then you can kind of indulge yourself by playing with the toys and then going, oh, actually maybe this wasn't worth it.
Yeah,
actually, one other thing I've actually found interesting, like on the topic of Go routines, is like, Rust came along, and Rust is supposed to be the super safe language, and nothing ever goes wrong in Rust. And I find that like a lot of the things they fix, things like concurrency, things like some type safety stuff, I don't find is usually the most like the bugs that I hit the most in Go. Like the bugs that I hit the most in Go are like things that will go out of memory, and then just the whole program dies. So I've actually been really fascinated with like Zig lately, because they do all explicit allocations. So I think that's an aside, really.
Yeah, I think that people tend to optimize in the wrong parts of their application, because it's like there's a place where you think it's like, oh, here's the place where the actual performance problems are happening, and then here's the other place where there's a bunch of fun stuff to do. And those are usually not overlapping spaces. So people tend to optimize things that it's just, you spend all this time optimizing this and you haven't really gotten any extra performance, but there's that giant ugly thing over there that no one wants to touch, where like 90% of our performance problems are.
Okay, do we have any other unpopular opinions?
All right, I'll go.
Go.
So just let me preface this with, like, I love the Go community, but you're allowed to criticize those you love, right? It's okay.
I hope it's Kris. I hope
right,
you're about to have a go at Kris and not me.
Yeah. So I think a lot of figures in the Go community like reject past teachings as like over engineering, or actually I'm sad to say, Kris, when you said, oh, that's Java thinking. And I was having some light bedtime reading a few months ago. I was reading Martin Fowler's Patterns of Enterprise Architecture. And I can feel all the Go community cringing because enterprise architecture, that doesn't sound very Go-ish, does it? And it was written like 23 years ago or something silly like that. But I was reading through it and I was realizing that, a lot of the stuff that has been discovered in terms of like patterns and best practices within Go, they're all written in that book. And I think a lot of engineers could do with reading some of these past teachings. Like some of it, you shouldn't like bike shed it entirely. Like you need to process it and understand it and apply it to the context. But I think there are lots of valuable lessons there that don't need to be relearned. We can pick up these books and look at them. So for instance, the classic thing that everyone kind of discovers or has to do some Googling about is how to structure my HTTP handlers, right? I think, Matt, you've written a post about it, and I've put a thing in my thing about it. Martin Fowler wrote about the pattern that basically everyone's kind of agreed upon, as I say, like 23 years ago. So mainly my unpopular opinion is read Patterns of Enterprise Architecture, and it will make you a better Go developer.
Wow.
I feel like
I don't disagree with the take itself. I think my caveat to that is that I really don't want to hear people just like dropping all the pattern names of like singleton and abstract factory, and like I think you lose a lot of context when people start using these special terms instead of staying within the context of kind of nomenclature of the language itself.
Yeah, I totally agree. Like, when we're talking about files and folders, right? So I tend to use ports and adapters, right? Which is a very kind of enterprisey sounding thing. But when I'm doing it in Go, I don't have a ports package because like Go is structurally typed rather than nominally typed. So that means I don't have to say this thing implements this port. It just does, right? I can just plug this thing in and it works, right? So I think when people are doing ports and adapters in Go, cool, that's a valid idea for some contexts, but I really don't see the value of making a ports folder with a bunch of interfaces in them like that. You just don't need that in Go.
Yeah, the knowledge is the thing that is useful. I feel like our industry tends to get very dogmatic about things, even when like, especially about older stuff. Like I think it's always incredible how people, for a lot of the stuff we're doing now, people are like, this is incredible technology we're building. And it's like, yeah, we built this in the 60s and 70s and then forgot about it for 40 years. Like it's not new. It's cool that we discovered it again. But I think a lot of the times we mistakenly take things from the past, misunderstand them, and like dogmatically apply them. I think that's the problem. Like the Pattern of Four book, I don't think is a bad book. I think the way that people, or the Gang of Four book, sorry, isn't a bad book, but I think the way people apply it is bad. So let me just take a bunch of patterns and slap them into my code, and then I'll have a good code base. Or when people don't understand like why something is the way it is, or like associate it with something else. Like my forever example of this is XML. Like people are like, XML is so terrible. I'm like, XML is actually quite fantastic. It's like far better than like JSON and other similar types for like a whole host of reasons. And like the reasons XML, the reasons XML, I mean, I guess that might be an unpopular opinion, but like, I still think the reason XML is unpopular is because like, partly because it's associated with SOAP, which people don't like, but also because like back in the day, it was slow to decode XML in JavaScript in the browser, and JSON was like free, so people are just like, let's use the free thing. But even like this whole JSON craze is relatively recent as well, right? I mean, like it's called XML HTTPR or XML RPs, whatever it is, but has XML in it, and it's like Ajax, the X's. Yes, there we go. And like we have Ajax, and the X in there stands for XML. So I think it's like sometimes we throw out old stuff because we have given it negative connotations when we really should be like, no, that thing wasn't bad. Some of the stuff we were doing with it wasn't great, but the thing itself isn't bad.
I think that's a much nicer way of putting it than I did. So thanks, Kris. Yeah, I think the astonishing thing about a Gang of Four book, just to round it off, is like it literally has in there prefer composition over inheritance. Yeah, I swear so many people have like taken a Gang of Four book and used that as an excuse to construct these like mad inheritance hierarchies from hell. And I have every sympathy with people say, please don't do this in Go. And the wonderful thing about Go is it doesn't have inheritance. It encourages composition over inheritance, just like how the Gang of Four book wrote 25 years ago, whatever it was.
It's a level of irony that we we come up with these beautiful patterns for things and these ideas, and the names we give to them tend to get completely inverse to be the thing that we were trying to move away from. Like this happened with object-oriented programming. It happened with relational databases, which I also was like another hill I will probably have to die on. Of like, no, all of our SQL databases aren't relational. Like if you actually look at what EFCOD or TEDCOD wanted out of relational databases. But I've just noticed over time, we keep doing it over and over and over. And it's,
we don't learn.
I hope we can do it differently in the future.
Is that a submission of an unpopular opinion about XML being good? Would you like to actually submit that? Because I reckon
Sure.
could win. That's an award-winning unpopular opinion.
XML
right
is good. I
The
feel
problem-
like my...
Go on.
I feel like my SQL, like no SQL databases or relational databases, are not relational databases, would also be confusing, if not unpopular.
Well, that sounded very interesting.
Yeah, I was curious about that one.
Yeah.
Yeah, I mean, I guess the short of it is that the whole point of why he came up with relational theory was so that the programmer did not have to care about how data was laid out on disk, and so you could just query how you want to query, and the database will figure it out. And basically, every modern database requires you to understand how the data is laid out to disk if you want it to function well. Like, we have to care about indexes. Like, most databases don't generate indexes for you, and you can write, and the way you write SQL queries is highly dependent on how the table structure, how everything's laid out on disk. Like, you know, the first thing that happens if you're writing if you're going slow is like, oh, you have to optimize that query to make sure it can run faster for the particular data structure that you have. When literally one of the reason why TEDCOD was like, I want this, is because it's like, programmers should not have to care about this. This is something the computer should figure out. So it's literally the opposite of what it is.
Well, it's funny, any of these kind of higher level abstractions, that's the promise. Like, you don't have to worry about underneath, you can just use this thing. But if you're going to really use it properly and use it well, knowing about what it's really doing, you know, that mechanical sympathy of what's actually happening down at the files and folders level, well, files, definitely, it might well change how you do things. So it's like, yes, it's one of those things where I don't want people to have to stop and learn everything before they can be useful. The opposite, actually, get going building things. But when it comes to it, like, it's really interesting to dig deep and learn about how something really is working under the hood for when it comes to optimize or improve it. Yeah.
I feel like there's like a nice phrase of like there's the idea of like especially for cryptography things, it's like, don't roll your own crypto. And I feel like the whole phrase of that should be, don't roll your own crypto and put it in production. Like, please do go implement crypto algorithms if you'd like. Just don't use them for anything real. And I think that applies to all of this. Like, I don't know, go roll your own little operating system kernel. Go roll a little file system. Like, go do these things. Understand how this stuff works. Because then you will actually know more about how the underlying thing is functioning that you're using.
Yeah.
I mean, I will say a caveat on that. Like, BoltDB was originally not meant to be for production. And it just eventually got there, so there is some danger in just rolling your own. I will disagree with you on the relational database piece. I think that I think it's relational in the sense that the select defines what you want the data to do, and I don't necessarily see like the DML, the data manipulation language, like or not DML, DDL, like create index and stuff like that as part of the actual relational model necessarily. It's kind of almost separate, in my opinion. So I think that from a select side, I mean, obviously there's ways to optimize a select, but you can adjust how it's implemented from an operator standpoint separately from the person that's actually writing the SQL itself. So
yeah, I mean, I don't want to say that that none of the databases that are SQL databases could be really. I think technically no, because there's other reasons why SQL is not relational. But on that point I was making, I think, yeah, you could have a SQL database that is relational. I just think that for the way that we practically use them today, they're not in spirit relational.
Yeah. And also Cod as well. I think if I remember this correctly, he was a mathematician and not actually a programmer himself. Or maybe he did some programming, but I think he was mainly a mathematician. So a lot of it was theoretical, and I feel like once you hit, like, tires hit the road, it's you got
Yeah.
those kind of performance issues.
Yeah, I think there's a whole host of reasons why things are like wound up the way they did. But yeah, I think I think people have like in the shadows been working on actually relational databases because the other thing about SQL is like SQL is not a relational language, and the people who created SQL deliberately made it not a relational language, which is one of those other weird things of history when you go trolling through the research and the papers. It's like, oh, like SQL, they were literally like, we don't think relational, like this relational model thing is great. We're going to create this other language that's specifically this other thing. So it's like a competing idea, and I think over time they kind of got merged together. Yeah. Weird. It's weird. I spent way too much time falling down this rabbit hole. It's
It's the whole thing. Yeah.
It's filled
Actually,
with
another fun fact is the SQL, like it was originally called SQL, the language, and like spelled out SEQUEL. But then another company had the same name and they couldn't get the rights for it, so they switched it to SQL. But now everyone calls it SQL, so I think it's kind of funny.
Yeah.
Oh, that's amazing.
Yeah, trademarks and all of that. That's why I'm always like, it is SQL if you want to be pedantic about it.
Mm-hmm.
Yeah. Kris, I feel like you should do an episode like Down the Rabbit Hole with Kris Brandow, where you just dig deep on something like that. Just tell us all the history about it and stuff. I'd love that.
It would be fun. I do have a number of topics that I'm just like, oh, is that how that's supposed to work? Okay.
I always think they're very interesting and learn so much, but unfortunately, it's not for today. It's not for now, dear listener. It's time to say goodbye. What did we learn about today? Files and folders. I mean, I feel like there's actually a lot we didn't even get to. There's the whole IOFS package, which is an abstraction on top of file systems. Maybe we'll do another episode on that another time. But yeah, so what did we hear about then? Well, start small and grow from there. It depends. I heard that a few times, and I think that's kind of an important takeaway here. Like, there isn't one structure that just works for everything. Don't just follow patterns for the sake of it. Find out what works for you. The patterns can be a useful metaphor, but make sure you actually understand the actual benefits. And then don't obsess over it and let it be informed by the design of your code rather than the other way around. I thought that's quite interesting. And I suppose be prepared for it to change. As Kris James said, if you're fighting with it all the time, maybe that's a sign that not all is well and it needs to be, evolved a little bit. And then be prepared to do that, because it's not easy. You have to sort of practice it. Think about you've got lots of people working on things. Big refactors are going to touch lots of things. They're going to be, difficult to get that PR in the normal flow. You have to sort of organize around it sometimes. So might be worth practicing. It's sort of like a teamwork thing as well. Lovely stuff. Well, thank you very much. We had some cracking guests, didn't we, Kris? Which one was your favourite out of Ben or James?
I don't pick favorites.
Right.
What's yours,
Just
Matt?
text me. Kris James.
Yeah.
It just answers it. No, not really. I couldn't pick. It's like choosing between your kids. If your kids are, your age or slightly younger. I don't know. Younger. Slightly younger. No, I'd never be able to choose. Kris James, do you have a favourite on here?
No.
Okay.
You're all wonderful.
Yeah.
Everyone's wonderful. The audience is wonderful. There you go.
The audience is wonderful. Yes, thanks for listening, everybody. We had Kris James, Ben Johnson, Kris Brandow, and me, Matt Ryer. We'll see you next time on Go Time, shall we? Yeah, why not? See you next time. Yeah. Bye. Yay! We did
That's
it.
really loud, right?
Yeah.
It is a bit loud.
It's pretty loud, yeah.
I know. It's on full, isn't it?
That was
Could
good.
have turned it down, actually.
Some self-reflection. I feel like this is like my 5th time on the show, and I still feel like I need prompting, and I'm sorry about that. But yeah, it was good.
Well, no, it was great. Yeah, that's great. Very interesting stuff. We are still live. We're still on the YouTubes.
On the YouTubes.
Yeah. So do you want to say anything else before we sign off?
We did miss quite a lot, didn't we? We had a lot of
Did we? Have to
material.
jump back.
I feel.
Yeah.
Oh no. Does this mean we have to do another? We have to do a part 2?
Yeah, just a different folder. I
I
think
think we got most of it actually.
a lot of it. Yeah, a lot of it did
Yeah, I
actually
think
come
we did a
up
good job.
in the chat. Nice stuff. Good.
Although now I feel like we need to do an episode on relational databases.
Yeah, I do. That's a great idea. Databases.
Yeah, they're quite important to the engineers. So, I can't believe there hasn't already been an episode on databases with Go. Surely it has been. But it's probably been a
remember the
files and
SQLite.
folders one, to be fair. I don't know.
Probably has been a database one. I don't know, Ben. We should come back. We should do an episode on
Dig it out.
databases. Yeah. From someone
We
who's
could do
written
a SQLite
databases.
versus other like client server databases.
Oh, well, I think
dig it out on that.
SQLite wins on that, but
Best database ever.
Yeah. All right, fellas. Thank you very much.
we can say bye to YouTube.
Yeah. Goodbye, YouTube people.
Bye, YouTubes.
Normally, I think people would have turned it off.
Oh wait,
Oh,
why
it's-
you're
It's
making
counting
us-
down.